So we've talked about rates of change as it relates to velocity. The change in the position function gives you the velocity function. Okay? But what about the change in the velocity function? The change in how fast I'm going over time. Okay? Am I speeding up over time? Am I getting faster and faster and faster and faster? Or am I slowing down? How is the velocity changing? Okay? Well, that's exactly what acceleration is all about. So the change in the velocity function is the acceleration function. So that means the derivative of the velocity function is the acceleration function. Or we say the second derivative of the position function is the acceleration function. Okay? So if I was to give you a very simple problem about acceleration, it's as easy as finding the second derivative. Okay? Again, acceleration is the change in the velocity over time. Is my velocity increasing? Is it getting faster and faster and faster, in which case I would be accelerating? Or is it getting slower? Is the velocity, the change in distance over time, is that slowing down? Is it getting smaller and smaller, in which case that's decelerating? Either way, all of it's called acceleration. Okay? So here's a very simple question. The position of a particle is given by this particular position function, where t is measured in seconds and s is measured in meters. Find the velocity at time t. That's the first piece. So let's just answer that question. So for A, I want to find the velocity. Well, the velocity should be the derivative of the position. So the velocity function is the derivative of the position function. This is a very easy function to find the derivative of. 3t squared minus 12t plus 9. Okay? At this point, derivative of polynomials should be no big deal. Next, what is the velocity after 2 seconds and also after 4 seconds? So there's two questions here in B. What is the velocity at 2 seconds and what is the velocity at 4 seconds? So I would say plug in 2, so 2 squared minus 12 times 2 plus 9, and plug in 4. And see what kind of answers you get. So velocity at 2 seconds is -3, and this is measured in meters and seconds, so meters per second. Okay? And the velocity at 4 is 9 meters per second. If you just think about it as speed, okay, the direction actually changed. There's two things happening here. One, this is negative and this one is positive. So the direction has changed, okay? This one was going either backwards or down, and this was either going forwards or up, okay? But also the speed changed, 3 meters per second versus 9 meters per second, in which case the speed got faster, okay? So then there's another question. When is the particle going to be at rest? Okay? So when is the particle going to be at rest? Which means when's it going to stop? Well, if it stops, the velocity would be 0. So essentially this question is asking, when is the velocity going to be 0? So for C, what we want to do is find out when is the velocity function equal to 0. So if I said 3t squared minus 12t plus 9 equals 0, let's solve it. So I would have to solve that quadratic. If it can be factored, I'd factor it. If not, quadratic formula. It looks like it's factorable. I'll pull out a 3. I get t squared minus 12t plus 3 equals 0. So I would get this is a 4. Okay. T squared minus 4t. If I pull a 3 out of here, I get a 4. So it looks like it's factorable. T minus 3, t minus 1. This will give me positive 3, but then negative 3t and negative 1t gives me negative 4t. So this tells me t equals 3 and t equals 1. So it's actually at rest in 2 times. This is when it rests at 3 seconds and 1 second. Okay? So here it was going one direction between 2 seconds and 4 seconds, 3 seconds, and then there it stopped, and then it started again going in an opposite direction, and that's why we have a positive. It also stopped before that at 1 second as well. But anyway, to answer C, the particle's at rest at 2 different times, 3 seconds and 1 second. Well, we still haven't factored acceleration into this problem at all. All this was just about velocity, which we've already covered. So here's now acceleration. So now find the acceleration at time t. And then what is the acceleration at 2 seconds and what is the acceleration at 4 seconds? Okay, so what do we have? We had our position function, which was t cubed minus 6t squared plus 9. We had the derivative of that, which was our velocity, to be 3t squared minus 12t plus 9. This was 9t, sorry. And so then the second derivative, which would be the derivative of the velocity, which is our acceleration, ends up being 6t minus 12. So what's the acceleration at time t? This is the acceleration at time t. The acceleration function. All right, so then E was the acceleration at 2 seconds, and then also what's the acceleration at 4 seconds. So the acceleration at 2 seconds and the acceleration at 4 seconds. The acceleration at 2 seconds would be 6 times 2 minus 12, which is actually 0. And the acceleration at 4 seconds is 6 times 4 minus 12. Now, everything was in meters and seconds, so this is measured in meters per second, and the same thing here. This would be, 24 minus 12 would be 12. 12, I have to do that. And this would be meters per second as well. Now let's make some sense of this. Just like the velocity, the acceleration can go positive, 0, or negative. Okay? If your acceleration is positive, which we have here, that tells me that you are speeding up. You are accelerating, the traditional of what you would think is acceleration. So a positive acceleration, you are speeding up. So at 4 seconds, our speed is increasing. So we have an acceleration of 12 meters per second. If you had a negative acceleration, so let's just say this happened to be negative, okay? It's not, but let's just say it happened to be negative. That would mean that you are decelerating. You are slowing down. And so we didn't get that, but that's what it would mean. So what about 0? An acceleration of 0. Well, acceleration of 0 means you're not speeding up or slowing down. Your speed is consistent, is constant. You are staying at the same speed. So an acceleration of 0, you are neither accelerating or decelerating. You are traveling at a constant speed. Okay? So that's what that means there. The velocity isn't changing, okay? Either positively or negatively. So here you see that it's actually pretty easy to calculate acceleration by thinking of it as the change in the velocity and just by calculating the second derivative.